Hello everyone, I am Jubair Hussain, an MSc student in software engineering at Kennesaw State University. I am currently working as a graduate research assistant under the advisement of Professor Hussein Shahriar. Today, I am aiming to present one of our collaborative research between Tennessee Tech University, Florida International University, Kennesaw State University, and University of Calabria. This paper, titled Ride-Hailing for Autonomous Vehicles, Hyperledger Fabric-based secure and decentralized blockchain platform. First of all, I would like to provide a scenario about transportation. Almost 3,500 years BC, people are used to use wheel carts, and that is transformed into carriage, and then steam locomotive, followed by motorcycle, diesel fuel tank, airplane, auto rickshaw, concept of shared cabs, bike sharing, and many more. And currently, we are witnessing autonomous vehicles. It's gaining popularity among the people across the world. In the meantime, ride-hailing and ride-sharing is also gained popularity among the people in order to get convenient and low-cost transportation. And all of the ride-hailing and ride-sharing application or transportation, they are centralized nature in traditionally. So in this paper, we are aiming to provide an introduction, research background and motivation, related work, framework, implementation, case study, security evaluation, load resiliency analysis, and finally conclusion. Our key contribution of this paper will be, providing a framework that we propose in a decentralized ride-hailing frameworks towards autonomous vehicle, because by nature blockchain technology creates trust between multiple non-trusting entities, and trust between participants in the network is provided through the chain code protocols that allows data security for different clients application to participate in the network. We also propose transportation system that would be agnostic in what it is not specific to autonomous vehicle ride hailing, and that could be used as a decentralized platform for standard human driving ride hailing. Ride sharing and service, it evolved since its inception to a large scale market as mass appeal has skyrocketed its profitability. It has been rapidly expanding since the launch of companies, for example, Uber, Lyft in US, and Grab in Asia. All those companies, they offer a platform for cooperation between riders and drivers through mobile application, and ride-sharing market revenue will be owed approximately $285 billion by the year of 2030, according to a report by Goldman Sachs. In autonomous vehicles that we will call AV, it uses sensors, for example, cameras, lasers, and electromagnetic fields detectors. And all the sensors, they feed the information into traditional artificial neural networks to make decision about how to operate the vehicle while on the road. The first system was autonomous land vehicle in a neural network, which we call also ALVINN. In this research, what is our overview is we provide overview of blockchain technology, which is first introduced in 2008 by one of the scientists from Japan, Satoshi Nakamoto. He is also widely known as the father of Bitcoin, Bitcoin also a peer-to-peer electronic cash system. Bitcoin works as a distributed append-only ledger where all information within the system is stored and accessed by concepted peers. There are different type of blockchain, which we can refer public blockchain, private blockchain, or consortium blockchain. In public blockchain, what we see is like miner participate in the consensus determination process, and the ledger is completely visible to all participants across the globe. And one of the example of public blockchain is Bitcoin. On the other hand, private blockchain is enterprise-based private network, which means that type of blockchain should be used by enterprise within their own network, and it will not be publicly open so that people can access those data. It will not that case. On the other hand, consortium blockchain allow only trusted nodes to participate in the validation of blocks, which means only certain people will be able to access certain type of data that is allowed for that specific trusted people. And private and consortium blockchain is popular for financial, healthcare, and enterprise-based field. There are different type of frameworks for public, private, and consortium blockchain. Ethereum and Hyperledger Fabric, two of them, which is widely used by different entities and researchers and practitioners. For the Hyperledger Fabric, it was introduced by Linux Corporation and IBM. And consortium blockchain, also known as Hyperledger Fabric, which means only Hyperledger Fabric offer consortium blockchain technology, and all the nodes must be certified before they can participate in the network. Supports smart contract in consortium blockchain by Hyperledger Fabric, also known as chain code. And for developing consortium blockchain, we can use different type of programming language, for example Golang, Java, or Node.js. On the other hand, if we talk about ride sharing and ride hailing background, rider request a specific ride from their current location to a specified destination, and using the different platform provided by companies. And all the ride sharing and ride hailing platform, they have some certain variables which we can call parameters, and those are, for example, ride distance, ride wait time, and the total number of rides given is important in order to calculate the payment, provide the scenario that how much a ride requester has to pay, and so forth. For our research, we found some related work. For example, for ride-sharing algorithm optimization, one of the researcher, Mr. Lee, and other researchers presents an enhanced ride-sharing matching algorithm that takes into account meeting points and preferable time windows. Gisberger proposed an approach to solve the problem from the perspective of optimizing rides section by selecting detours that maximize the serviceable area and minimize non-optimal driving routes. Another researchers formally defined dynamic ride sharing and the challenges faced when developing optimized algorithm in a DRS system. DRS known for dynamic ride sharing. For ride-hailing privacy, we know traditional ride-hailing services, for example, taxi, they did not require a strong privacy protection, as riders could remain relatively anonymous during transaction. One of the researchers proposes a framework for preserving the location privacy of riders and drives without compromising on functionality. Another researcher proposes privacy-preserving ride-sharing system that protects the privacy of users. We also study on smart contract security. One of the researchers, Mr. Farouk, proposes a Hyperledger Fabric-based system for storing and sharing EHR data within permission network and chain code permissions. Another researchers discussed common smart contract development pitfalls as well as their smart contract security education efforts. The author also discusses some logical errors and lack of data encryption. For blockchain ride sharing, we study different research paper. Mehdi Hassan is one of the researchers who describes a framework for multi-purpose dependable blockchain to be used as the communication platform for an autonomous vehicles ride-sharing system, and several cryptocurrency-based decentralized ride-sharing efforts either currently in development or that have been developed and are in the market as of today. For our framework, we used architectural model and the core components of the proposed Hyperledger Fabric architecture are organization, endorsing peers, channel structure, chain code function structure, client, and certificate authorities. If we look at the figure on the right, we will see components of a Hyperledger Fabric organization. So there are ordering nodes, peer nodes, clients, and certificate authorities, as I described before. In order to implement our architectural framework, we implemented using two organizations, both having two peers, an orderer, a certificate authority, and then multiple user accounts. The peers of this network are built using Docker Compose and run within separate Docker containers in a single Docker network. The client application currently run on the host machine and access the Hyperledger Fabric network through ports that have been exposed to the host machines via Docker. If we see the figure on the right, we will see the main interface of our application, and then we will see another picture which is for the location tracer of our application. In our implementation, we use chain code protocol. Chain code functions that are installed on endorsing peers is critical. The distinction between individuals, riders, and drivers is done within the chain code by creating unique user ID and then utilizing these IDs within the chain code functions. If we look at the figure on the right, it displays the functions provide the core functionality of the proposed framework. So there are different type of functionalities. For example, register user or unregistered user, request ride, accept ride, set ride destination, pick up rider, drop off rider, leave driver, for instance. We conducted a case study and we performed synthetic case study demonstrating the execution of our blockchain-based ride-hailing platform. So if we look at the picture that is given on the screen, we see there is a driver and the driver can pick up any rider from location A, location B, or whatsoever. So for simple co-rider scenario, a simple ride-hailing situation is depicted in the figure, as I said, where two riders R1 and R2 request a ride from driver D1. And what driver D1 will do, driver D1 first pick up rider 1 and then it will drop off rider 1 in location C and then pick up rider 2 from given location, and the driver will drop off rider 2 at the destination of D. In our case study, we provide a co-rider scenario. So ride request, in that particular thing, it will have ride ID deliver driver ID, status, pickup location, drop-off location, pickup time, drop-off time, co-ride ID, co-rider pick location, which is pickup location, co-rider drop-off location, and we see in the picture. So we also study, threat taxonomy and proposed mitigation. For example, we investigate Sybil attack and Eclipse attack. We also investigate malicious ledger query and packet sniffing. We also study, malicious client application. For the chain code analysis, we utilize a static analysis tool for Hyperledger Fabric chain code called chain security. We adopted the design patterns in non-determinism or state that could be exploited by malicious actors in the system. For load resiliency analysis, we perform traffic engine or performance, traffic engine or PTI. We utilize the PTI tools to test our implementation under load. PTI enables testing live Hyperledger Fabric networks within various chain code orderers and peers. The test cases, processed a total number of 6,000 transactions for a total 1,000 riders with varying transaction rates. In picture A on the left and B on the right, it reflects a single test case. We also conducted constant rate network traffic, position distributed basic network traffic, organization restructuring test. In figure, we can see on the right is depicted a figure where we can see different type of Raspberry Pi. All are like a test bed in shown, where each Raspberry Pi was running Ubuntu 18.04 image that was designed for ARM architecture. Here is some of the result of road resiliency analysis. On the left, we can see peer latency with differing numbers of peers, and in the middle we see peer latency, and on the right we can see transaction per second for network statistics of organization recognition test. In conclusion, we would say proposed framework, for building a decentralized ride-hailing application that serves as the intermediary platform connecting drivers and riders. The chain code protocol described in this paper provides security transaction through design and could be extended to many applications. The implementations utilized permission nature and built-in organization structure of Hyperledger Fabric to detail an optimal build for organization of independent driver. The organization now allowed to create their own client application and still be able to interact with the Hyperledger Fabric network and share the load of the riders. Based on our proposed architecture, we found that after conducting different experiments, both riders and the organizations will be benefited significantly in order to gain the trust, provide the transparency and protection of data in order to, for the both riders and organizations. Our reference was cited from the paper that is to be appeared in IEEE Big Data 2021 conference as a full paper. So if you have any questions or if you want to know anything, please don't hesitate to contact me. You have my email address on the bottom left corner and my LinkedIn account on the right bottom corner. Thank you very much for your time and patience to listening to this presentation.